estimating linear regression. First off, what is regression? Well, regression in a statistical standpoint is intuitively a predictive analysis on the outcome of two variables x and y. Ultimately, these multiple plot points that are observed from the dependent and independent variable provides an outlook of how the trend of the data is established. After the points are plotted, we can apply a guideline that establishes a linear path of regression. The graph in the bottom right corner of the screen shows plotted points with different variances, which creates a path for the estimated values to fall upon. An example of simple regression is the correlation between height and weight variables. The shorter an individual is, the less weight they will be. The taller the individual is, the more weight they will be. These factors are predetermined to be true because as humans we have set the basis for height and weight to be positively correlated from birth to adulthood. If an individual is of short height but heavy weight, a compensation amount is included to control the level of output of the appropriated value set. This compensation is known as the error control value, thus not interrupting linear path of regression totally. How can regression be applied to engineering? As we can see from the graph, our two variables include time, which is in years, and airbag errors recorded. A regression of increasing airbag errors develop over the progression of 7 years. Vehicle manufacturers can use this data collected to implement any if needed recall notices on airbags of certain make, model, and years of vehicles. This regression model provides an easier estimation of what is to happen in the future. Why is it important? Why do we use it? Linear regression helps estimate the strength of direction of the plotted values. Without linear regression, we cannot see the relationship of the variables being observed, thus not knowing what estimated values will follow. Ultimately, we can determine whether or not values are valid or not, following the linear path. Thank you for watching.